Hello guys, so thank you so much for joining this session, and we'll be heading into our Raspberry Pi connectivity. So yesterday we were able to see something with respect to our application. So how we are able to connect remotely and then through Wi-Fi and through terminal, and we have seen how we are going to connect with the VNC terminal as well. And then we have seen how we are going to connect with the Raspberry Pi. So online guys, you might have missed this class, but we would be providing that as a class file. So you would be providing this as a video file to you. So and sooner or later Teja will be sharing that video, right? So we'll give that. And yesterday we were able to see the Raspberry Pi configurations, how you're going to interface with serial, I2C, UART, and SPI, and then the connectivities with respect to Bluetooth, Wi-Fi, and Ethernet. So we have seen that. This is my IP address, so which is in my local machine, so in our local network. So 192.168.1.3, and Pi is the user, and password is capital P at the rate SSW0. For the classroom guys, you can connect this. For the online guys, you cannot connect right now as of now, but we are making some arrangements so that you can reach the Raspberry Pi and then do this work as well over internet from any network, right? So you can try getting into that, and then we can connect to our systems. Sorry? Yes. So you need to connect to Wi-Fi here. So 605, yes. Yeah. Round table is the password. Round table. Yeah, all smalls. So Wi-Fi here is quality thought 605B, and password is round table guys. So you can reach this and use this one. Okay. So you can connect this. You're able to reach? Okay, fine. That's Putty was able to do it. Okay, that's fantastic. So now, yes, you need to get it in. So you have Mac, right? So you don't have. You can use terminal. Yes. You have the terminal, right? Yeah, that should be good. SSH. No, no. You're using Windows, is it? On Mac Windows. Goodness. Okay. So this is the first time I'm hearing someone from the Mac family using a Windows system. That's nice. So you have a dual boot sign. Okay. That's nice. Okay. So if you are using Windows, go ahead and install Putty software, and then you would be using something like this. And when you are using Putty, right? So you need to do this thing. All right. So Putty Windows, and so when you look at this, right? All right. So Putty will look like this, and you need to provide the IP address here, and then 22 is a default port. I didn't change it, so we can change that one. And 22, and then open. Now, once you open it, it'll ask you for the username and password. You would be providing this username and password as a login. Right, so login credentials for Raspberry Pi. All right. So you're going to connect these two things and then do the work. All right. So let me connect back, and all right. So I'm opening my terminal and just I'm trying to connect to that. Okay. SSH Pi, and then if you are using any Linux or Mac terminal, this is how you need to connect 192.168.1.3, and then enter. It'll ask you for the password. Provide the password. All right. So you are inside the Raspberry Pi. All right. So if you click on, if you issue a command called ifconfig, you would get the IP address and then which network you are in. All right. So here I have both the networks. So here Ethernet is available, also Wi-Fi is also available. Since I didn't connect anything to the Ethernet, so it is not showing me the IP address over there. If I connect the LAN card, it will show me the IP address over there, right? So, and we have a LAN, WLAN, which is connected, and then this is a MAC address of that, and then this is the IP address of that particular thing. And this is a broadcast IP, and there's a net masking. So there's a net mask which is available. So you are able to connect to this particular network, right? So sudo su and then clear. So in this case, today what we are going to do is we're going to install something called Mosquito MQTT server, so which would be used as part of our communication part. So let's fix all of these communications and everything, and then we'll deep dive into the applications part on it. So and then we'll go with the Node-RED installation. And so Node-RED is another one, so another application wherein it will provide you a graphical way of doing the coding part, so programming part. So if you are not good at Python, so if you don't want to write a lot of codes, there are predefined set of objects available. You can just configure them and then do the same task what you are dealing with the Python. So I'm gonna give you both alternatives. You can write in Python and do the work, or you can, if it is a straightforward task, you're not doing any business logic over there, you're just taking the dump and then pushing it to the cloud. Yes, you can use Node-RED in that case. All right. So to reduce your efforts, you don't have to go there and then do this work and all. So I'm going to do that. So for this, we are going to use some Node-RED server. All right. So this is purely based on Node.js application. Node.js application. All right, you're going to do that. So this Mosquito is based on Python application, is built on based on Python application. We can use that. So right. So and then what you're going to do is we are going to install this application, guys. All right. So first thing is we need to install Mosquito on Raspberry Pi. Right. You're going to install that. Okay. So especially where do we use this Mosquito? So just want to give that insight. So for example, let's say you're having a YouTube channel. All right. So YouTube channel, and you have a channel. So for every account, there's a channel associated with it. So if I subscribe to your channel, whenever you have uploaded any code, right, any video, new video, I will be getting an intimation saying that there's a new video available on this particular channel. All right. So this we can use it for our IoT devices. So and especially for transmitting the data and all, we're going to use this one. In this case, the YouTube, what you call, is a broker in our case. All right. So YouTube will act as a broker. All right. The person who is uploading the data is called as publisher. All right. The one who is receiving the data, or one who is viewing that particular video, is called as subscriber. All right. Here in this case, you can see there are a lot of devices, and then we see a broker, and we see other devices also in this case. All right. So some are you can see forward arrow mark and backward arrow. There is a two-way arrow mark, and then some like for example, let's say house, office, lamp. All right. So lamp is nothing but we are just receiving that particular instruction in this case. All right. So kitchen door, all right, so something like this, and then windows door, it is a one-side information. All right. So that means like whether your office lamp is on or not, that data is being pushed into the broker. Whenever this office lamp is pushing the data into the broker, this broker will check who are the subscribers for it. Right. Where do you see the orange part? Device, the third device, right? This third device is a subscriber. That means this device will receive that data. Okay. So this device will receive that data. So that means it has an arrow mark towards it. Right? So this device can publish the data and receive the data complete. Okay. So these devices, what you're talking, are trying to send some data and then receive some data. This a single device can act as a subscriber, as a publisher also, both the things. All right. So in our case, let's say you are trying to control an light, and also you want to take the temperature information. All right. You want to take the room temperature information, as well as you want to control the light. So taking the room temperature it device will take the room temperature and it will push to the broker, push into the broker. The broker, what it does is it's going to check who are the subscribers for that particular topic, and then it will push the data to them. All right. So in our case, what we are going to do is, so broker being our the mediator, broker being our mediator, Node-RED, what I'm talking is the other end application, where that application will receive the data from our devices. All right. So our devices, IoT devices, will generate data and push it to the MQTT, and MQTT to the Node-RED. All right. So I'm going to show that right now. So how we are going to send that data, and then how you're going to receive that data. So here in my case, I have set a small example here, guys, and let me take that one more time, and then, so don't worry about this code. I'm going to explain that later now, but just let me take one small example. Pub sub client. Yes, here it is. I'm gonna take my ESP8266 chip, right? So I'm gonna take this sensor data and push that sensor data into this chip. And from here, I'm gonna take that data and push it to the MQTT. And from MQTT, I'm gonna pick it up and then show it in a Node-RED screen at the back. All right. So that's exactly what we are going to do now. So SSID is nothing but our local thing. So it's quality thought 605B. And then when you talk about this, all right, so it's round table. I don't mind if someone took this data. So, and my local MQTT server is running on 1.1.3. So this is my local MQTT server which is running, and my topic of data. So I'm trying to push some hello world application. I'm going to set this up first, and then later I'll come back and show how to get the data also. So I'm going to upload this code. All right. I'll quickly go into MQTT server and check if MQTT is running or not. So the command to check whether my service is up or not. So this is like service mosquito, right? And then status, right? So it is already running now. All right. So it is already running now. So it is up and running. And then I'll go into this and check if my node is running. So it is not running. Let me go ahead and start that one. So node tac red tac start. This is the command. So it is up and running. Let me go back and restart this. Okay, now you can see a Node-RED application which is coming up. Okay, I'm gonna take out all of this and try to apply this. So in this Node-RED application, so these are the inputs, right? So where are we getting the data from to Node-RED? We are getting it from MQTT server, right? So that is like, so here in input section, you find something called MQTT. Just drag and drop it, and we have something called just like how we are trying to print statement and show some error messages in the console. I have something called debug in this, and I'm going to drop it here, and I'm going to pick this up and connect to this. All right. So in my case, there's something called debug console, so wherein I can see the data here. And but before that, I need to configure the MQTT server here. I'll come back here and I'll go with the local host because Node-RED and the MQTT both are running on the same server. So I'll go with the local host and update that. But I need to give the topic here. The topic will be coming from out topic. Out topic is the one which has been configured there, and then deploy it. Okay, and now you can see. So you're receiving the data, right? So my node MCU. So let me open my node MCU and so show that this is an IoT device. Sorry for that. Now you can see you're getting this data here, and I'm pushing the data onto the node itself. Okay, you can see it, the 68 consistently. Whenever the data has been pushed from the device, it is going to the Raspberry Pi and reaching that Raspberry Pi, and it is pushing the data, right? So now let me go into the settings part. So now you know what we are trying to do. You are trying to send the data from IoT device, pick that data and push it to the Raspberry Pi. On Raspberry Pi, we are using MQTT server as a medium, and then that server is picking up the data and pushing back into the Node-RED application. Node-RED is the one which is saving all the data. Why I'm showing you Node-RED means, so here I would like to show one option. Uh, what do you see here? What do you see here? File, right? So if I have to save every data which is coming in into the file, it's just one click, drag and drop it. Just need to give some file name, test file, and then it'll append all the, so I'm just trying to give some Node-RED data. So I'm just trying to create that, deploy it. All right. So whatever topic you're getting, it will be directly saved on the Raspberry Pi as a file itself. So this will make your job easy, because you just have to dump the data. You need to pick the data from a file, right? So this is how you're going to simply save that data into the file. All right. So everything is available. So now we'll go with the actual setup part. All right. So yes, I'll do that. So VNC, and then find it. So to do a remote setup, so you can use, so the same password, guys. All right. Is this the one? It depends on the SD card what you're putting. So you're trying to prepare the flash file, right? So here you can see that flash. So everything is being stored on a sample file. So from here you can pick this data and you can use it for your analytics part. So if you are trying to make some decisions based on this data, yes, you can use it. All right. Or if you want to save this in a local database server, SQL database server, yes, you can do that. That job is also can be done. Or if you want to push it to any cloud, all right. So let me show you one sample example also, the cloud part as well, so that we can have a full-fledged conversation here. So, or let me take IBM Watson Cloud. So not this one. So IBM Watson, and I want to push this data to IBM Watson also. All right. So let me open this, and then done. Deploy it. You need to deploy the code all the time. So when you're trying to do, if you open it here, so here it says connecting. So let's wait for it. Now you can see, right? Hello world 183. So this is on IBM platform. I'm directly pushing the data into the IBM platform. The same way you can connect any number of clouds. Like here you can see, here you can see IBM Watson. So similarly, using this particular MQTT, right? I can push it to any cloud, like AWS. I can push it. I can push it to the Azure, GCP, any cloud. I can try to push it. All right. So, and one more thing is, so if you don't have any pellets, any supporting clouds, like you can go ahead and search for that also. That is also possible for you. And so, for example, if I have to go here and then search, and then go into installation, and then you can search for Azure, right? And then you can install that particular Azure into this also Event Hub. You can just go ahead and install this. Once you install this Event Hub into this, right? So you can push the data into AWS Azure Cloud also, which is possible. And also you can try this one. So the end of the day, you have all of that particular possibilities. Even the SQL also, if you have a local SQL database, you can push the data. All right. So I'll stop it here, but I'll come back to this particular full-fledged Node-RED setup and everything. So let me go back and try showing you that. All right. So when you come back to the prerequisites, so we said we would be using the Mosquitto, right? So Mosquitto is nothing but a broker which is available for you. And why we are going for a broker? First question. Right, if you are having a question like why we are going for this broker, what is the basic necessity for it, and why we are, what exactly is the main feature of this particular thing, right? So if you think about in that terms, this broker will help you to send data simultaneously into as many as clouds. Come in, please. As many as subscribers at a given time. All right. So minutes before, one of my classroom student, he was asking, so whether I can send data simultaneously to 100 subscribers. Once I push the data, can it be reaching 100 subscribers? Yes, it is possible, because Mosquitto will take care of that. But if you go with any HTTP concepts, right, HTTP concepts will take a lot of time, because through REST API you need to push, and there is a lot of complexity associated with that. So we cannot go with that approach. So Mosquitto MQTT has that flexibility to push the data to thousands of clients also at a given instance. All right. So that's a major advantage we have. So, and it is very quick and very fast also. For example, let's say if you want to collect 10 samples in a given second, 10 samples in a given second, that means 1/10 of the second, we can generate data and we can push the data back into the cloud. So that flexibility is available with respect to our NodeMs MQTT. All right. So that's the reason this is very familiar and widely used across any asset tracking management, or let's say car tracking, Uber, right? So Uber is also using internally, the Uber is using MQTT server. That means in each and every mobile phone where driver is having, right, driver information is pushed back into the cloud using MQTT server direct. So all this information is available there, and Uber is collecting all that, and then they are trying to show you at this area the cab is available, something like they're trying to take that in a reverse way. So instead of instead of just what they're trying to do is, from mobile phone they are trying to get the latitude and longitude and take the data and push that into the MQTT server. Here in this case, I was able to show you some, the hello message is being pushed into the code, right? There they are trying to push the Google Cloud platform. So Google coordinates into the cloud platform. All right.
This phone doesn't have any GPS, right?
Which phone?
Normal or mobile phone.
Regular phones has the GPS, but that is done through the triangularization techniques. So wherein when a particular, so let's say car is here, right? It is going to take the coordinates of three towers which are available, nearest three towers available, and then it's going to give you some accurate version. It is not accurate. Some band will be available. So for example, even if you open your mobile phone, right? So in Google Maps, it shows some red band, but you're not exactly pointed at the place where you are. All right? It might be showing that I'm in this building, but where exactly I am, it is not available in that. But with respect, yeah. Yes, it shows Amirpet Metro, or it shows the other building, but not exactly accurately. All right. So, but with the help of GPS receiver, what we have in IoT devices, it can show on which level also. Like if I'm here in 6th level, right? It can show me the 6th level also, which is possible because altitude is being calculated by the sensors. How fast I'm going, how quickly I'm doing the work and all, right? Even that is possible in this case. Okay. So with that, so let me go back into the installation part, right? First thing is you need to go with the update part, right? So let's go ahead and open my terminal. So this is my terminal, right? So I'm going to close this for a minute. All right. So this is the update. We need to run an update, and then we need to run this particular installation part, right? So let's wait for it. Okay, I'm gonna close this because it's already been updated, right? So, and then if you run this particular things, right? So sudo apt install mosquito and mosquito clients, right? Mosquito will install the MQTT server what we need, right? So mosquito clients will install the subscriber and publisher coding part. Okay, so that is available. So here it says, so it's already there. So it's because it's already there. So but and it is already the newest one, so it doesn't need any upgrades or installation part.
So for
Now,
this, we
hmm,
need to type the sudo application.
yes, you need to provide this particular code. You need to do this job. All right, sudo apt get install apt install or tag y. So we are pre-accepting that particular terms and conditions, and then we are getting the mosquito and mosquito clients. All right, so both the things. Mosquito will install the MQTT broker. Right, mosquito clients will install the subscriber and publisher coding part. Right, where you're going to do that. All right, so I'll quickly go ahead and give you a short demo. So I'll open one more terminal. I'm gonna connect one more terminal. All right, so there we have done the installation. Now I'm trying to show you some sample example. All right, so sample tests and all. Okay, so to run the subscriber, right? So this is a command mosquito quitto underscore subscriber, right? Underscore sub mosquito underscore sub tag h and the IP address. So since I'm there on the local host itself, I'm gonna give the local host. All right. So and tag p. All right, so tag p is a port number. So the port number where MQTT server is running as 1883. All right, so 1883 and tag t. Tag t is nothing but topic. All right, so I'm going to go with out. So let's say IoT demo. I want to take a different topic in this case, IoT demo. All right, so and now I'll come to the different terminal. So and now mosquito underscore pub. This is a publisher, guys, and then tag h. So local sorry localhost tag p 1883 tag t topic. What is the topic? IoT demo. So the same topic. So in case of YouTube, what I was mentioning, the channel name, all right, or the account name is the topic what we are talking. All right, so here in this case a topic is nothing but the way we are trying to. So today AI with IoT class is my topic and it is your topic. I'm publishing the data. I mean to say I'm doing the lecture part and you are receiving it. You are a subscribers. Okay, so that's as simple as such. And then I'm trying. So whoever is a publisher, he has to send some data. All right, so in that case I'm gonna send something called tag t, and then I'm going to push the data back into the cloud. So tag t, and then I want to send some data test app. All right, I'm going to send this. Okay, so oh sorry tag m. So tag t is already a topic, and then tag m is a message. I'm going to send this. You can see it here on the other window. So let me send some other data app one. Yes, all right, three. All right, so it is all available. So whatever data I'm trying to send, the subscriber is taking that and then trying to do. I'll do one more thing. I'll open the terminal on my Mac and try to be a subscriber to the same topic, and I'll try to show that as well. So let me take the terminal. This is my Mac terminal, guys. All right. All right. So clear. And in this case, I have already installed Mosquito on my local machine. So you can mosquito underscore sub. All right. And then tag T, tag H. So in this case, I need to provide IP address in this case because I'm out of that particular thing. 1.3 tag P and 1883 tag T, that is IoT demo. All right. So anything else? We're good. All right. I'm going to enter this. I'm going to come back here and send it. Okay. I'm trying to get the data. All right. So I have done this particular job. So yeah, if you observe here, so I was not, I didn't subscribe for the topic till the one is happening over. So it was here in this case, this data was already been there. Later after this, I have subscribed for my on my Mac machines. So from then onwards, I'm receiving the data. This is what it is. Same thing in the real world also MQTT. So we'll give the data whenever you have subscribed to it, and then from then onwards, it will give you the data part. All right. So whatever data you are trying to push, it will come into the picture. All right. Now what I'll do is I'll take the Node-RED and I'll take some data and I'll try to push the data onto the same topic. Okay. And then connect this and localhost. Ours is IoT demo. I'm gonna give the topic there and in timestamp. So I'll take timestamp in this case, and which is like and I will try to give that on an interval base. Right, for every 1 second, the data will be injected directly into this. Okay, I think I have stopped the Node-RED server. Let me go back to one of the terminal. No tag red tag start. I can automate the enabling parts by using this particular code also. I mean to say like whenever my Raspberry Pi is booting up, I want to bring up this particular Node-RED server also. Yes, I can do that job. Right. So here in this case, yes, it is connected. Okay, it is connected. All right, I'm gonna deploy my code. Okay, it says it's connected. Here also it is connected. This is a cloud part, but here it is demo. Okay, so here I have given the interval part, right? So done this, no changes. You can see arbitrary data which is coming into my coding part. All right, both in the different channels. So I can send data from my device to the Node-RED. I mean that is a receiving end application wherein I can save it there. From Node-RED, I can send data back into some actions back into the device so that it can do some actions for. Okay, both the things you are able to see through Mosquito. So Mosquito being a major part here. So middleware which is trying to help you to do the communication part. So in IoT guys, most of the infrastructure is built on top of MQTT. If you take cloud, right, cloud has implemented MQTT server on that. All right, so every cloud has implemented their own MQTT server on them, and then they are trying to expose yourself into that and then trying to help you out with this. Okay, all right. So here we have done we have taken a topic which is coming from the Mosquito, and then we have showed you, and then again we have taken a timestamp and then pushed back into the same thing on a different topic, and the other device was able to receive it. All right. So you might ask me a question, sir, am I receiving that on my Node-RED, Node MCU or not? So I'm going to show that also. But here in this case, My in topic is little different. So what I'll do is I'll change the topic name. Here it is on in topic, but ours is on demo, right? I'm gonna show this. I'm gonna change the code on the this one. I'll try to show that. It'll take a couple of minutes.
One question.
Yes,
We
yes,
have
please.
a publisher, subscriber, and
Mm.
the server, right?
Yes,
Three things.
we have three things in this.
So subscriber will typically receive the message.
Yes,
Publisher will publish it. Where is, I
yes.
mean, what is the part of the server in this?
Mosquito, that's a major part. So whoever is publishing the data, so they are publishing on a topic.
Okay.
All right. So the job of MQTT broker is to pick up that data and pick up that topic and check who are all the subscribers.
And
So this is acting as a mediator, just like the name broker, the same thing.
so typically, I think it's a queue kind of thing, right?
Yes, queue kind of things. Yes, it is going to receive all the data. It is not just queue. It can receive simultaneously 100 or 200 channels also. 200 topics also possible. It can receive simultaneously 200 topics and it can distribute to 1000 subscribers also.
The topic is the one where you say if you open up a
Yes,
channel and then start sharing the
yes,
message.
exactly, exactly. This broker is responsible to pick up the data which is being pushed on a topic and send it to the subscribers who are subscribed to the particular topic. Okay. Here in this case, Node-RED is a subscriber for us. It is receiving that. All right. So tomorrow, cloud will be the subscriber. We'll be pushing the data into the cloud. Or your laptop is a subscriber. It will push the data into your laptop. Same thing. Right. So
Between the Raspberry Pi device and the
Mosquito, yes. So there's a close relation wherein this one is trying to push the data into the Raspberry Pi. On Raspberry Pi, it is receiving on the MQTT. So
for example, you want to do some kind of optimization or some changes to the received data.
mm-hmm.
In that case, you do it in Mosquito itself, or
So if you want to do some data changes on the server side, yes, we can do it. For example, let's say,
for example, you receive a temperature 20,
yeah,
and you say 10 minutes, you are plus 10, something like plus
okay,
5.
okay, yeah.
So changing the degrees.
Yes, yes, got it, got your point, got your point. So if you want to do that, we have something called function here or a template. We can use this and we can manipulate the values what you're going. So for example, what I normally do is I get the digital data, but the cloud will not accept the digital data directly. What it does is it's going to accept something called a JSON formatted data. I have to upload the data into the cloud in a JSON format. Then what I do is here in this case, function, I'll get all the data and then raw data. In function, I'm going to prepare the JSON file and that JSON file, I'm going to push it to the cloud. So all these modifications can be done. Possible. Possible. So class, online guys, so there's a question in the classroom. So can we manipulate the data what we are receiving from the device and then send it to the cloud? Yes, we can do that. We can use something called functions. We are going to. So we'll do this as part of our NPOC. So when you're doing the POC part, we'll be doing all this collaborated work. So as of now, I'm trying to give you the bits and pieces. Right now you have seen the way how we are trying to communicate from one place to another place and how you are receiving the instructions from one place to another place. Yes, you're going to do that. Once you have done this, next part is we're going to interface our device with different sensors with different interfaces what we have seen yesterday. All right. So I2C, SPI, and UART, and all these things. We are going to pick the data and then we are going to push that data back into the cloud.
This load is given on the device or the MQTT?
Sorry.
The data manipulation load, because we need some code and it is some load.
Yeah, yeah.
It is given on MQTT or the device. The Raspberry Pi processor will do that.
Well, Raspberry Pi will do that. So whatever broker you have.
Can you distribute the load into MQTT or some other big machine?
Okay, so you mean to say like, can I distribute?
This is simple anyway.
Yeah, yeah.
Some adding or something. If we want to do a big data processing.
Oh yeah. So if that is the case, what you can do is, so we have something called on on cloud we have something called Node-RED is also available. Okay. On cloud we have Node-RED available, so wherein you would be connecting your device directly into that Node-RED instead of here. I'm just showing you that on Raspberry Pi we can do it. On cloud also it is available for you, so wherein you can push the data back into that and then
Intervention,
yes,
it will be in the cloud and it will automatically does.
yes. So if there is no problem with the connectivity part,
We don't need to open.
provided that we have the connectivity part, so we have the constant communication between the server and then the other one. So if you have that data, that connectivity, so there's nothing will stop you guys. There's nothing that will stop you. Yes,
The
sir.
device means Raspberry Pi or this sensor.
Device means,
The all
see,
inclusive.
yeah, all inclusive. So either it can be from a chip like this, which is an external one, or I can connect the same sensor to the Raspberry Pi and pick the data from it.
What is
So
this then? This
sorry,
this is the controller.
this is a microcontroller, so Node MCU microcontroller. So this is hardly like, this is 300 bucks, this is 120 rupees, so hardly 500 rupees you get this particular device. You can do this data.
So the RAM and the processing that
Can you expect the RAM size of this?
no. I mean it is in the Raspberry Pi. The
The memory size, memory.
Even this has a memory,
but in the
but
cloud
very less, like kilobytes.
kilobytes.
Kilobytes of memory will be there available in this case. Hardly, it's a 2 megabytes of memory, total memory, and 1 KB of RAM. Can you guess? 1 KB of RAM. So even our laptops have bigger RAMs actually. So
But
1 KB
Raspberry
of,
Pi will be having more.
yes, Raspberry Pi will have bigger RAMs, like 1 GB RAM is available. DDR3. DDR3 1 GB RAM is available. So that is little faster process.
But using this Node-RED,
Mm.
we can receive the data, process the data, send it back to cloud or some other application.
Yes.
But we cannot send it back to the device again.
Yes, you
Device will
can
not
do that.
accept.
Yes, you can do that. Yes, you can do that. I'll show that. Okay. So do you see this? So let me go back. Okay, what is the port? Give me a second, guys. Okay, download it. So this baud rate should be proper, right? Do you see this? Publish message, IoT demo. Whatever data we are pushing from the node RED, you're receiving it here. Do you see that? IoT demo. We are receiving the same data. This device will also receive, can receive. So this can be a publisher as well as a receiver also, subscriber also. All right. So encoding, I can show you that. So like here in this case, so subscribe to your topic, publish to your topic. Both the things are possible.
In real world cases, like you receive the temperature and then you bring it to the board controller and then process it in the system or the cloud. Then decide whether to switch on the water something pump or something,
Yes.
or switch
Okay.
on the motor.
Yes.
Then send it back, and then this device will take care of switching on.
Yes, it can take. So that doesn't make like for example, let's say if you are trying to send the data, so if you are trying to make some decisions and you are connecting the sensor and the actuator motor onto the same thing, it's better to take a decision here and inform the decision back into the cloud. So here in this chip itself, I can take a decision and then uh, switch on the motor, whatever, and then I inform that decision onto the cloud. So that is easier.
Okay, then it is going to be a different process.
Yes.
There
If you are trying to take, for example, let's say here in this chip I have connected the temperature, and in another chip you have connected a motor. In that case, you can take it to the cloud and then push it back to that device. That is possible.
If suppose the taking the decision is a computational challenge, then
Mm.
I think you can't do it in this. Right?
Yeah, if it is like if it is not on the same device, if both sensor and actuator are not on the same device, then you're going to make decisions on the cloud side. So that's a part of architecture. So when architects think of this, so they think of a lot of solutions like this. Okay, if it, whatever it is feasible, they try to figure it out and then include that in this case.
For complex algorithms and all, we cannot make it here.
Yes, yes, exactly. So, complex things, it's always good to do it on a different machines or a bigger machine, something like that. So it is always good.
We just need the signals. What is
Yes,
happening?
yes,
Data,
exactly.
and then we have
Exactly. So online guys, do you have any questions? So we are able to see the data, so which is coming from one machine to another machine. So and then from cloud, and from Raspberry Pi, so we have seen IoT devices sending data to Node-RED, and Node-RED sending data back to devices, right? So we have seen both the cases. Okay, so in both the cases we are using MQTT as a medium. MQTT as a medium. So for sending data, we used publisher. Receiving data, we used subscribe. Okay. All right. So this is what, and then we have installed the Mosquito and then Node-RED server, both the things. So both the things we have done. So please remember these terminologies. This is more important when you talk about IoT in any interview. They are first gonna ask you what is MQTT, because MQTT plays a major role in this particular area. So you should make sure that you have sufficient knowledge or practical things on this thing, and then you're going to do the data part. So you can connect to my Raspberry Pi, guys. So classroom guys, you can connect to my Raspberry Pi and then push the data, which will help you out this case. Okay. Any questions?
You know the MQ20 now we are using the drag and drop the GUI.
Yeah.
Can we code?
Can we?
Code. I mean, like.
Yes, you can code that part also. So using Python, you can do all this job. So you can receive the data, you can push it to the cloud, you can generate some data from the Python code, and you can push it. You can publish that data to the MQTT server. All of this is possible. So why I'm showing you this one is this is pretty easy, and this is widely used as industrial standards. All right. Instead of you spending time on writing the code and then trying to do the job, if you have customized things, if you have a lot of customizations, then I would suggest you go with the Python code and then you write the code according to your requirement. If you don't have if you can go with the generic requirements, generic tools and all, just go with the Node-RED. That is way more better.
This may be resource intensive. This one.
Yeah.
Coding maybe it's a slim.
Yeah. So basically, like for any coders like you guys, yes, you can go ahead and do this job. All right. So
It's a like to
it's a free. That's free of
we can
cost.
write additional functions also like customized also.
Yes, you can do that. You can do that. So you can write your Node.js applications, pellets, and then you can write applications and build it, and then you can do that. So not a problem. See, whatever node you have, right? So you're seeing some node here. This node can be, you can write that node using Node.js application. It's not a big deal. All the TCP part, all the cloud part on it. So all of these things are possible. So you can do all of this, and we'll proceed from here from tomorrow class. All right. So we'll proceed from here into the other sessions also. Right. So just possible. Hope today's class is a little helpful for you guys. And I'll ask Teja to share this video to you, because I have done certain steps at a very fast rate. Please go through the video, and if you have any doubts, you can ping me back anytime. Right. So or you can ask me 15 minutes before the class so that I can explain you on that. All right. So not a problem. So any questions, guys? Online class, online folks. Showram Srikanth.
We have to tell,
Hi Srikanth. Yes.
we have to let Teja know some email ID.
Yeah, you can just give your email ID to Teja, so he'll be able to share that particular details.
So we are having three micro raspberries
Mm-hmm.
on the same topic. One is publishing, one is subscribing.
Mm-hmm.
Is there any data clash such that loss of data will happen?
No, one
So
is subscribing and one is publishing.
we talked about single publisher and multiple receivers.
Yes, yes,
Subscribers.
yes.
My point is here,
Uh,
multiple publishers and multiple subscribers. And
that,
sometimes same topic will be there.
yeah, you can do that, not a problem. So here you're trying to publish, you're trying to publish the data here, right? So let me take another one. Let me take another inject thing, right? What I'll do is I'll try to push the same data back into your MQTT part, but this time I'll push something else. All right, so I'll try to push some JSON file, so which is like okay. So this is a JSON file. Let me copy it and I'll push that data. All right. So now the topic is IoT demo. You know, doing this one. All right. So and again I need to change the injection part. I'll give a time interval for every 1 second. It is going to show. All right. So I'm going to clear this, deploy it. All right. So all right. So you're trying to push the RPMs data, and then you're trying to push it. Okay, everything is good, and you're trying to push it on IoT demo, right? So everything is good here. So let me go back and open my terminals. You see this? You get both the times. Here you are getting the time. Here you are getting the JSON file. So there is no clash. Okay. So multiple subscribers, multiple publishers, which are possible. But when you're, like for example, let's say on a single topic, if you are trying to send multiple data, then there'll be a hectic job for you to streamline those things. So there'll be a little problem over there. So that you need to handle it properly. So for any typical design, it's always good to separate the things and do the work and separate the work and do this. So normally if you say like you would be pushing this data back into the table and then trying to do this, yes, you can do that. Okay. Hope I answered your question. So any questions, guys, online folks? All right, again. All right, then have a nice day and we'll see you tomorrow class. All right. Thank you so much.